Hello. How are you doing today? Okay, how old are you? Okay. What do you do for a living? What is your name? Hi, John. How are you doing today? I'm doing great. Actually, I'm going to join NYU as a researcher soon. Where are you from, John? Do you like math? Okay. What is mathematical optimization? Wow, look at this. Do you know what Bitcoin is? Okay. It's a cryptocurrency. Do you know what a cryptocurrency is? Okay. What's the temperature where you live? Is that Celsius? But wait, where do you live? What do you think of Elon Musk? I mean, yeah, Tesla is a really good idea for humanity. Yeah, what do you think of electric cars like Tesla? What excites you in life? Okay. So is your name John? Do you get stressed and disappointed at times? Tell me more about your stress. Okay. So how do you get over stress? Okay. What is your most favorite book? Oh, okay. Do you read the Quran? Oh, wow. Do you know that we're in Ramadan right now? What do you know about Ramadan? Well, yes, that's correct. What you just saw was a chat between an AI and myself. Perfect. I simply wrote some Python code that uses my microphone with PyAudio acting as a middleman to synchronize Python with my voice. And I'm also using AssemblyAI's API, today's sponsor, as our audio-aware intelligent AI brain, who takes my speech in, then transcribes it back in text form. I'm also using OpenAI's GPT-3 as the AI's brain, who listens to my speech in text form, then responds with human-like text. In what comes next, I will show you detailed Python coding on how to get this human-AI conversation going. We will install Python packages along the way, get our AssemblyAI API ready, then perform the AssemblyAI API calls in an asynchronous way. And this code is highly inspired by the following GitHub repository, which I also link down in the description section below. So without further ado, let's get started. So before we start building our human AI chat, I just want to, start by installing locally some useful packages. First one being is Streamlit. So Streamlit is really a very easy front-end Python package that just makes it very easy to write some Python code using some very basic functions. So let's get this installed. I already have it installed locally. And the next thing I want to show you is how to install PyAudio. I first started by typing in pip3 install PyAudio on my Mac, but that doesn't work. What you have to do before is run a brew command. So brew install port audio in the beginning. And then I want to install PyAudio using pip3 as such. Third thing is the WebSockets Python package, which, as the name says, we're going to use it to be, communicating with AssemblyAI and GPT-3. And last but not least, GPT-3 requires you to have this package called OpenAI, which is the company that, created GPT-3, right? So once done, now we're ready to, start writing some Python code. So the first thing I want you to do is start by creating a config.py, and this config.py is where we're going to store our API keys, right? So we need an authentication key for AssemblyAI, right? Which goes here. And we need another authentication key for OpenAI or GPT-3, right? So for that, we need to sign up. So for AssemblyAI, you go to this link, get started. Since I already have an account, I'm going to sign in. And here's my API key. I'll be pasting it here. And next, I'll be doing the same thing with OpenAI. So for GPT-3, I'll Google that. I'll go to OpenAI, log in. Since I already have an account, I'll just sign in as such. And I'll be using my API key over here. Now next, I want you to create your main.py, right? This is the main that's going to be, talking to AssemblyAI and GPT-3. So the first thing we want to do is start by importing our packages of interest. So we want PyAudio, first of all, to access our microphone, right? Just close this to make me some more space. Next thing I'd want to import is WebSockets to communicate properly with AssemblyAI and GPT-3. Next thing I want to do, since, in case you didn't know, when you're talking to APIs, this requires a lot of, await and synchronizing properly. And for that, we're going to be using Python's async.io. Next, I'll be using base64 and JSON as a way of packing my information to talk to AssemblyAI and GPT-3. Next off, since I'm using this config file over here and I don't want to show you the API keys, well, one way of keeping that hidden from you guys is by importing config as such and importing authentication key assembly and authentication key for OpenAI. I was just joking about the API keys. This is another way for you to keep them, in another safe file where if you want to change them from time to time, it would be better to go into the config and do that yourself, right? It's more organized. Last but not least, to create a nice looking app for that, we'll be using Streamlit as ST. Okay. For the OpenAI key, the way you should tell OpenAI, hey, OpenAI, I've got this key, is by setting the key as such. So in OpenAI.API_key, you pass it the authentication key that we just, saved in the config.py. Now, another thing we're going to be doing is, since I'm using my microphone, right? I need to define some parameters, right? You can't just start using your microphone just like any function on Python. You need to pass it some parameters to synchronize with your voice. So for that, we're going to open a stream. We're going to define first a Pi audio instance. So let's call it P. So for the Pi audio instance, I'll do this dot Pi audio. And then I'll do P.open and I'll pass it some parameters like format. So for the format, as you can see here, it's an integer. You're going to tell it at how many bits you're going to quantize your audio. For that, we're going to use, there's many, you've got 16 bits, 24 bits, 32 bits, 8 bits. I'll go for 16 bits and then I'll pass it the channels. I'll do channel 1, but in case you're using multiple microphones, you should change this accordingly. Then you pass it the sampling frequency or the rate. For the rate, I'll be using 16,000. So this is measured in hertz or samples per second. This actually means that this is the number of samples that are grabbed from your voice, of your actual voice per second. So how many samples I'm going to buckle up uniformly in 1 second. And for that, a typical value would be 16,000. Next, I'll set the input to true. And lastly, I'll set the frames per buffer to be FBS, where FBS is predefined over here. So right here, I have some parameters and I'll set it to 3200. Okay, so this is what you have to do for your microphone to sync with Pi audio. Now next, what I want to do is configure Streamlit. So let's give our application a title. Let's call it AI Human Chat. Also, in case you didn't know, Streamlit divides your graphical user interface into so-called columns. So in this column, we're going to have 2 buttons, one for recording and the other for stop recording. So for that, I'll define start record and stop record in my second column. I'll have a statement that is going to be originated by the speaker, which in this case is me, initialized to something empty, and a response from GPT-3, which is in another column. As such, the response will be initialized also to be something empty as such. Like in many other applications, we're going to define a button, we'll call it record, and we should give it on click a callback function, which we will define as toggle on. Likewise, I'll define another button called stop recording, pass it another callback function called toggle off. Let's define the callback functions somewhere here, callback functions, and we've got our toggle on function, which we will set the session state of recording to true, and likewise we will define a toggle off function where we will set the same state to false. Okay, and as an initializer for the state, we will initialize the state right over here to false only if we are not in a recording state. So if recording is not an st.session_state, I'll set this guy to false. Now that we, initialized our Pi audio, we synced it to our microphone, we defined some front-end functionalities. Let's now define our AssemblyAI endpoint as such. Now in the documentations, if we're going to, use real-time streaming transcription, we have to, connect to this endpoint. So assemblyai.com/v2/realtime/ws and pass it the sampling rate that is 16,000. So I'll be using this URL as my endpoint, right? As such. And that's basically it. So now we can plan our send and receive WebSocket functionalities, but first we need a main wrapper, right? And since I mentioned that we're going to use AssemblyAI, which is a library to write concurrent code using the async and await syntax. If we go to, the documentation of AssemblyAI, here's, the hello world of AssemblyAI. So as you can see here, you've got the def main, you pass it the keyword async as such, you write your code with the await keyword, right? And then you run this block of code using AssemblyAI.run, pass it the main. So I'm going to copy paste this block right here, and since I'm calling this main, I'll just rename this guy to send and receive, okay, as such. Now, since I'm going to be, using input outputs like so, I need the statement that is given to me by AssemblyAI, and I also need the response from GPT-3. So those two are inputs that should be written as such. Simply like you pass inputs as arguments to any given function. You have to do so on AssemblyAI. So now let me get rid of this and start by typing async with websockets.connect, since we want to connect to our URL over here, right? So this is the proper way to do it. In my connect, I'm going to pass the URL as such, some extra headers for authorization. This is a clean way of doing things. So this is where I pass my API key, which if you remember is auth_key_assembly. So I'll pass it here. And next, we can define some parameters like the ping interval. Let's set it to 5 seconds. And the ping timeout. Let's set it to 20 seconds. Now this guy is going to return a WebSocket. So I'll do as WS. And right over here, we're going to await. For awaiting, you typically pass a sleeping time, as you saw in the documentation. Let's pass it 0.1. And then once we're connected, the session is ready to begin, right? So for that, we do await WebSocket.receive as such. And then we will define two functions over here, two async functions, the send and the receive. So let's start with the send. I'll comment the receive for the moment out. So here's the thing. We're going to read the audio thanks to Pi Audio. So microphone to audio, where Pi Audio is the interface. And then we're going to use this audio to push it to AssemblyAI so that it transcribes this audio to text. It does speech to text conversion. So we're going to send it using this async block right here. And we're going to do this using a loop. So while my session state recording is true, we're going to try the following. So we're going to take the data, going to read, pass it the frames per buffer, and pass another very important thing, which is the exception on overflow. If you don't pass this, you will see that in your front end in Streamlit, you will be faced with many exceptions. This is a safe way of, just preventing any overflow. Next, the data is going to be encoded using base64, B64. This is very classical in audio. So you encode it as such, and then you use UTF-8 format. Next, you're going to wrap everything you have in a JSON format. So you go JSON dumps, pass it a JSON type as such, and you convert your data to string. You pass it the data in a string format, and then you're ready to send everything you have in a WebSocket. You pass the JSON data as such. But since we're, talking to APIs, you cannot just do so. You have to run an await call, and you wait for it. Now, in case something goes wrong, we have an except block, exception as E, and you can assert to false. Okay, in case you want to, know what's going on, you can print an error to your terminal with the code of your exception so that you can go to Stack Overflow and see if there's any guys getting similar exceptions. And last but not least, we're going to set AssemblyAI.sleep to something like 0.01. And then I'm going to return true. And one last thing I will tell you about is the following. This send block is good. However, since you're using AssemblyAI's API, you might run into, you have exceed the limit of using our API. And not because you used the API too much, but because you left it on. So you have to tell AssemblyAI that I have stopped using your API. As simple as that. So according to AssemblyAI documentation, when you've completed your session, clients should send a JSON message with the following field. You should set in a JSON format, terminate session, the parameter, with the value being true. So the way to do so, you will want to test if you're not in maybe there's a better way of doing it, but I found this way to be okay. If you're not in recording mode, right? You're not in recording mode. You're not recording. You're not using the AssemblyAI API. Just tell AssemblyAI that you're done. And a nice way of doing that is using the WebSocket. You always talk to AssemblyAI using the WebSocket, as we did here. So here's the WebSocket. We sent it the audio in a string format, decoded in UTF-8. So you send it, close API data, and it's a JSON, so JSON dumps. And I'll pass it, the JSON, according to the documentation. This is the parameter. I'll copy paste it, terminate _ session. So terminate _ session, and I'll pass it true as such. So this is the guy we want to send through the WebSocket. And remember, every time you send something, you have to await. So we go await as such. Okay, as simple as that. So this is it for our send block. This is how we talk to AssemblyAI, okay? And this is how we close a session with AssemblyAI. So now let's start with the receive block. Notice that here we only sent the data in a string format to AssemblyAI. We're still expecting the response, right? So for that, again, while we are in recording mode, we're going to try the following. We're going to receive from this WebSocket. Remember, we have this WebSocket here. Well, it also applies here. So this WebSocket, we're going to receive the transcribed text and a result in a string format, a result _ str. Again, every time you send, you have an await. You should also, with the receive, have an await as such. Since we are recording, at any given time, AssemblyAI is capable of knowing if you're done talking or not. Am I clear? So you should, while you're in recording mode, each time test whether this is the end of your sentence, okay? This is very important. So if we are at the end of the sentence, we are ready to display the text. We're going to check if we're done talking. Once we're done talking, we're going to display the sentence. So this is done as such. JSON.loads result _ str message type. This is the name of the field. If this is the final transcript, we're going to have our statement first, initialize it to empty, and then we're going to set its header to the result we have, so it's found in text. And this is safely done as such, so you have to have with statement.container as such. Okay, so at this point we are done loading our transcribed text. You can also test for any exception. Remember the try block? Well, it should always have an except block as E, exception as E, assert false. Okay, so this wraps up everything we need for AssemblyAI. This is the send block, and this is how we receive it. Okay, and this function send receive should output send result and receive result. As await, you do a sync. Since those are outputs, this is the way to run both function send and receive. Now let us test this. So we go streamlit, run, and main.py. So let's start by clicking record. Hello, how are you doing today? I'm going to NYU. And there you see that we're really able to get AssemblyAI working properly. So that's one main functionality of our application. The second one is that we need to get to talk to a certain AI. We need to get a certain conversation going. Now we need to grab this text and send it to GPT-3, right, through OpenAI. Then GPT-3 will respond with some human-like text, okay? For that, we're going to define a state here where we need to know whether GPT is running or not. Initially, it's not running. And so after we get this text, we're going to launch GPT. So it's right here where we will launch it. And our current prompt is the text that we're going to pass it to GPT-3, which is basically all this text. This, I'm going to pass it to GPT-3 as such. Okay? And then I'm going to wait for a response from GPT-3. So this is me asking a question, or it could be, I'm taking part in the conversation, right? So this is the guy that I'm going to pass it. And the way to pass it is as simple as that. So OpenAI dot completion, okay, dot create. First, I'm going to define an engine, which typically is, you've got many engines, but one that is popular is DaVinci. And I'm going to pass it the prompt as such. So it's the current prompt. Now here you've got a lot of parameters to play with. So for example, you can ask, hey, how are you? You can get a response as, oh, okay, I'm good. Or you can get another response as, not so good today. So those options are in this n parameter, which you can set it to any number you want. Let's say 1 for the moment, okay? Say I want only one response. And yeah, let's see what that gives. So for the response, I'm going to initialize the response field to empty, and then I'll get my answer. My first answer is in this response, or my only answer for the moment, because remember, n is 1, is in response. And, here's your choices. So since n is 1, I've only got one choice, and it's indexed as 0. And I want the text field. And then the respond field right here, which we have defined using st as one of the columns, is going to be, and its text field in particular, is this answer. So that's about it. I hope you found this video beneficial. If you did, please leave a like on the video, subscribe to the channel. If you have any questions whatsoever, kindly leave a comment down in the comment section below. I'll make sure I'll get to it as soon as possible. I'll see you then.